Hello, this is Greedy Angel, and I got a math problem for you today for my new series, A Math Problem a Day. So, what I want to do today is linear algebra with matrices, starting just a little bit of that, because I think it's one of the most simple things to learn, but yet it looks kind of advanced when it really isn't. So, and we're going to just do a simple one, easy one. Now, linear algebra has to do with lines and solving where there's solutions or no solutions or infinite many. It's not really that complicated. You guys have been doing similar problems like this in middle school or in high school. Basically, you have two linear equations. These two are lines on a graph. By now, in linear algebra, you usually use one variable, x1, x2, and then you continue from there. But this is kind of like just a system of equations. If I change that x2 to y's, then you're like, oh, it looks just like a system of equations where, I'll solve x and then I'll use that to solve y. Which honestly, that's all it is. But later on, you're going to have way more variables to solve. And so we change our use of tools. Instead of solving that way, we use matrices. And matrices are not that hard. So you see your problem? Look at the coefficients. Coefficients are just the number in front of the variables. All right. So I have my numbers in a new sheet. I'll rewrite the problem. x1 plus 5, x2 equals 7. -2, x1 minus 7, x2 equals -5. All right, so I'll make my matrices just these little boxes, little brackets. And I'm just going to write the coefficient, and it needs to line up with the equation. So my coefficient here is 1. When the variable has no number in front, you assume that it is 1. Then my next variable is positive 5. And then my answer is going to be 7. So this is what we call argument matrix. I can't really say it right, but that just means I include the answers as well in my matrices. So now I'm going to write down my -2, -7, -5 for my second matrices. Now this is simple because all you need to know is how to multiply, divide, add, and subtract, and you can solve it. So those are my options. I can either add the first row to the second row, or add the second row to the first row, or subtract them, or I can multiply the whole row by some number, or I can multiply the bottom row for some number, or divide. Same thing with divide. And what my goal is to leave off eventually with 1, 0, 0, 1, and that's going to equal some number to some number. Reason why, remember, coefficients is a number in front of the variable, and then when a variable does not have a number in front, you assume is 1. So this is just saying x is equal to this number, because 0 times any number will be just 0. So this is like saying 0x2. So I'm not going to write that because 0 times any number is 0. So here you have x2. This one's, remember, this cancels out the x1. So you just have x2 equals some number. So you can see how having it like this solves the matrix. So back to my problem. All I got to do is get this here to that form. And to do that, Well, I have 1. I want to multiply it by 2. I want the opposite from the second row. So when I multiply 2, and 2, positive 2 and negative 2 are opposite. But I have to do the whole row so it can be equivalent equation. So it'll be 2, 10, 14, negative 7, negative 5. This is a 10. Looks like a plus. Now you just add the first row to the second row because these are opposites and I know they're going to cancel out. So this becomes 0, this becomes 3, and this becomes 9. Now since this row is equivalent to the first row because I multiply every term by the same number 2, I can just rewrite the first term. It's the same equation. And the reason why is because I have that 1 where I want it to be. I want it to be 1, 0, 0, 1. Now the second one, I want this 3 to be a 1. How am I going to do that? Divide any number by the same number. I get 1. So if it's 3, I'm going to divide by 3. Divide 9 by 3. 1, 5, 7, 1, 3. Now, I want this 5 to disappear. If I make this 1 the opposite of 5, then I can disappear by adding. And I'm not going to affect what I did first because this is 0. And any number times 0 is 0. So, rewrite the first row. Multiply the second row by negative 5. And then you saw that I have multiplied every term. But because zeros, any number multiplied 0, 0, that still stays 0. Okay? But I'm multiplying by negative 5 because I want the opposite of positive 5, negative 5. Now add the second row to the first row. Second row, I can convert it back into 0, 1, 3 because they're equivalent equations. And I'm done. It's in the form that I wanted to. So this is saying x1 is equal to negative 8. x2 is equal to 3. And I can always test my answer. So my first equation, I had x1 plus 5x2 equals 7. Plug in negative 8 plus 5 times 3. Does that equal 7? Well, that would be 15 minus 8. So I'm going to need, I can do it over here. It'd be negative 8 plus 15, and that does equal 7. So this is good. And then, of course, since it's a system, I have to check the other one. So negative 2 x1 minus 7x2 equals negative 5. Plug in negative 2. Always put parentheses when you plug in. So it would be negative 8. And for x2, I want to plug in 3. Just like that. And this equals negative 5. So negative 2 times negative 8, that's going to be positive 16. Because 2 negatives equal a positive. And then minus 7 times 3 is going to be 21. And now I check, does 16 minus 21 equal negative 5? And that's going to be yes, because 4 to 16 is always 20. 5 more, that's where you get your 5. Keep the sign of the bigger number. And you're done. See? Pretty simple for matrices. Hopefully you learned something for today. I'm going to try to post another video tomorrow. I'm going to try to do these daily. And it's going to range between high level math, easy math, all levels of math, wherever I'm interested for the day. You guys can also leave a comment, subscribe, let me know what you guys want to learn, what kind of problems you guys are struggling with, and I'll try to solve it for you guys. And I guess that's it for my first video. Have a good day.